Tonight we are blessed to have Mr. Turner, Larry Turner, with us. And I'm going to go ahead and read you a little bit of background on this. Anybody that's interested in shirts, Sandra's got the sign in for shirts. So they like what we're wearing today, with the exception of where I've got this patch here. We're actually going to have the new emblem for the museum. And we're less copying that of the CAF. Okay, Larry Turner was born in Huntington, West Virginia in 1938. Moved to Tucson, Arizona in 1966 to accept employment at Hughes Aircraft Company Missile Systems Division. Larry began his career as a senior designer working on the GAR-11/AIM-47 Falcon missile, which you're probably going to get into and explain a little bit in the presentation.
1953, Howard Hughes founded the Medical Institute and made Hughes Aircraft Company a subsidiary of that. Now, he went to court with the IRS because they said, you can't do that. He said, yes, I can, and he won out in court. So Hughes Aircraft Company was actually a subsidiary of a medical foundation that got tax breaks from the government. Okay. Smart man, smart man. By 1985, largest single private employer in both Arizona and California. 6 major divisions building lots of things, and it was the largest defense electronic firm in the U.S. Some of the things that were built: fire control and radar systems. Hughes was at the forefront of the electronics industry. Tactical guided missiles, we'll talk about. Lots of satellites. At one time, every satellite circling this world was built by Hughes Aircraft Company. Not true today. They still have a few up there. Ground support, seaborne radars, communications, and air traffic control systems. 30 years ago or so, the government, U.S. government, decided they wanted to revamp their air traffic controls. Hughes bid on that. They lost. I don't remember who won it, but Hughes lost. But Canada took it, and the U.S. eventually had to replace what they bought. Canada's still using the same things that have been upgraded. So we talk about the missiles. How did Tucson came about? Well, Hughes wanted to have a production plant for the guided missiles, but he wanted to have it away from the coast because you remember we had just come out of World War II. Lots of concerns during World War II, Japan invading the West Coast, things like that. So Hughes Aircraft wanted to put a production plant inland somewhere. And they finally found a spot on the south side of the airport down in Tucson, in a sparsely populated area with nothing but rattlesnakes and cactus. Today there's housing developments all the way around it, and those people are complaining about Raytheon being there, but nevertheless it was all desert. Incentives. Hughes Aircraft was offered a number of incentives to put their plant in Pima County and in Tucson. Things like $1 a year in tax. Okay, we won't charge you property taxes. Come bring your... And it was a smart move on the government's part because, you know, it was looking at hiring 10,000 people in little Tucson, which was a tremendous boon for them. So there was a number of incentives to get Hughes to come there. 1951, they constructed the plant. Del Webb constructed the plant, and it was simply to build Falcon missiles. I put on there, don't mess with Howard. Once they had the building erected and they were starting to hire people, Pima County and the city of Tucson came back to Hughes and said, remember those incentives we said? Well, now you got your building up, we need to tell you, we were just kidding. We're not going to do that. We're going to go ahead and charge you all the taxes. So Hughes said, to hell with you. He sold the plant to the U.S. government for $1. $1. And that way they couldn't tax it. It was U.S. government. And today, that is USAF plant number 44, and has been since 1951. Plant site itself, 13 acres under roof. The largest tactical missile production company in the free world. We had a Tucson Engineering Laboratory. It's interesting now, the plant in Tucson was a manufacturing plant. Canoga Park had the design engineers for Missile System Division, but we had to have an engineering organization located in Tucson to support that manufacturing. So they built the Tucson Engineering Laboratory, and it was Canoga Park reps that were in that laboratory, and that is where I worked for my years. Had a receiving and inspection area, as I was telling somebody here earlier. Most parts for missiles and aircraft and things like that are built by outside vendors, and all you do is put the things together. So we had a very large receiving inspection area. But what made it unique, and what the people down there are complaining about now, is we had bunkers down there for warheads and rocket motors. And that's what made that plant very unique, because we could do all the loading of the missile, put the rocket motors in it, do all the final tests, and when the missile left Tucson, it was ready to fire. An example, our primary competitor, Raytheon, built their missiles up in Massachusetts. Then they had to send them to Tennessee to be tested, loaded up and tested, and then they'd send them back to Massachusetts to be shipped out. Well, all that running back and forth with missiles is not good for them, so they frequently had to return them to Tennessee to be tested again. Didn't do that in Tucson, all on the one site. In the 1980s, because of the boom in business, we built 3 new engineering buildings there on site. Each one of them a little over 100,000 square feet. So big facility by then. This is what the plant looked like when it was first being built. The roof is not on. You see the runways for Tucson International. This is the Nogales Highway running down here. This is a spur line from the railroad, and that was later extended on through here. But that's what the plant looked like when it was under construction. The new buildings, when they were built, were over here. So let's talk about the missiles. The granddaddy of all of them was Falcon. Falcon was the first operational air-to-air missile in the military inventory. Now, Sidewinder was close, and so were several of the others, but they were not the first. Falcon was. 3 versions: radar, infrared, or known as a heat seeker, and then, believe it or not, we had a nuclear-equipped Falcon missile. Very good missile. More than 30 years was in the inventory, and we produced more than 52,000 in all varieties. So, as I mentioned earlier, 1946 received a contract for Falcon. Now, it may not seem like such a big deal today, but radar guided. And remember World War II? We all seen the World War II movies. Great Britain had the great big towers for radar so they could pick up the Germans coming in from France, and all this infrastructure and buildings down below. The government told Hughes, take all of that and put it in the nose of this little tiny missile. Took a while to do it. Initially, Falcon was to be an intercept missile to equip bombers. The first tests were on B-25s and A-26s. They were not on fighter aircraft. They were to be on bombers so the bombers could protect themselves. 1952, contract for an infrared equivalent. And you see the time here, and you'll see in a moment, we delivered these in 1956. So it took 10 years to develop the radar-guided missile, and because of the work done on that, a little less time for the IR. They decided early on that putting these things on bombers was probably not the right thing to do. So they decided they would put them on fighter interceptors. The Falcon missile, and this is important, the Falcon missile was designed to be carried internally, not externally. And the first airplane was to be the F-89 Scorpion, followed by the F-102s, the F-101, and the F-106, which the missiles were all carried in bays underneath the airplane. You see the indications here, the abbreviations here. GAR is what the government called them, guided air rocket. Industry called them air-to-air intercept missile. So both of those, that was the radar and the IR, entered service in '56 and first equipped the F-89. How big was it? Well, we got all that radar stuff into a little missile. 6 feet 6 inches long, only 150 pounds. Only carried a 7.5-pound warhead, but that was enough if you hit the guy, and a range of 5 to 7 miles. Here's a couple pictures. You see the radar guided here. You can tell the IR from the radar because the IR has a little glass nose in it. The radar guided missile does not. Here it is on the wingtip pods. These are IRs, although you can't tell from this picture. So that's the F-89, and you can see it was carried in the pods. They went to fire the missile, the doors flipped open, the launcher came up with a missile, it fired the missile, and then everything went back in the pod. Okay, as time went on, lots of things changed. Electronics were moving ahead at a tremendous pace. Things like transistors and diodes and flat packs and all that were coming along. So a number of design changes happened to Falcon during its lifetime. Could get larger warheads. We were able to save some space in the missile, put in a larger rocket motor in that unused space. So you can see there was lots of changes. Interesting, the initial missiles did not have a proximity fuse. That's a fuse that would detonate the missile when it got close to a piece of metal of some kind. It read the anomaly detectors. So later on, they did have the prox fuse. Larger rocket motors, increased range, transistors replaced vacuum tubes. The original Falcon missiles had vacuum tubes in them. We went through a refurbishment right after I got the Hughes in '66 to take those vacuum tubes out and replace it with solid state circuitry. And edge circuitry replaced hard wiring because the early Falcons just full of wire harnesses everywhere. So we went to the edge circuitry. Here's the family. You see the various types that came about and the different designations given to them by the military. So it was it came in a large number of variants.
Larry, were any of the Falcons used in a wartime scenario from Korea to?
Getting to that. Good question, Bill asked if any of them were actually used during combat, and yes, they were. But you see how the missile grew a little bit, or a whole lot over here, and we'll talk about these two. These were the normal Falcons carried on the 102s, 106s. Okay. AIM-4D misapplication. Anybody here in the Air Force during the Vietnam War? Okay. When you talk to the pilots that flew the aircraft during that war, and you happen to mention Falcon, what you usually get from them is, oh yeah, Falcon. Well, that Falcon 4D entered service in '63, about the same time as the F-4 Phantom was coming in. The 4D had an improved seeker, but during the Vietnam War, the U.S. Air Force wanted that missile on their new airplane, the F-4. And Hughes said that's not a good idea because the missile is built to be carried internally, not externally, and the F-4 did not have an internal weapons bay. But they insisted. And we also said it's not a dogfight missile, it's an interceptor missile. If you're flying along in an F-102 or an F-89 and you're going to attack an enemy bomber coming in towards you, you have time to compute the closure rate. You can understand when to arm your missile, when to fire the missile. If you're in a dogfight and you're twisting and turning with a MiG and you all of a sudden have him in your sight and you want to fire the missile, you can. But the missile will be stupid. It won't track. I'll tell you why it won't track. The detector material in the receiver, and you send out a radar signal and you get a signal in return. But the signal in return is greatly diminished over the one that you send out. So in the receiver, you have a detector, and that detector enhances the return signal from the target. Okay? Well, it has to be cooled. The optimum was 321 degrees Fahrenheit. How do you cool that thing? Well, you got a 2-minute supply of liquid nitrogen on board. Now, if you're in a 102 and you're ready to intercept a bomber, you can say, I'm within 2 minutes of interception. You can turn on that nitrogen supply and cool that detector so it will pick up the return signals. If you're in a dogfight with a MiG, you can't do that. And actually what we found is many of the pilots would taxi out on the runway and turn on their cooler and use up that 2-minute supply before they ever took off. So the return signal coming back to them in a dogfight was not optimum. So the missile did not work very well. Also, carried externally. In some of the tests over at White Sands, they put the Falcon on an F4 and they ran it supersonic, twice the speed of sound down to El Paso. And it ripped the front wings right off of the missile. Tore them completely off because of the burble coming off of the airplane. We found the worst was when they had 500-pound bombs up in the center launcher on the airplane, and it sent out all this airflow, and the missile, I watched high-speed film, the missile would sit and twist and turn and literally tore everything inside out of it. So it wasn't designed to be carried externally. 54 launches in Vietnam. We've got 4 MiG-17s and 1 MiG-21. And I talked to one of the pilots who got the MiG-21, and he said the guy just made a stupid move and flew into the missile. The missile didn't hit the airplane hit the missile. So, not very successful, and what Hughes equated that to is taking a football to a soccer game. Try and play soccer with a football, or vice versa. So, finally figured that one out, and it was all in the taper of the bobbin. Like I say, it was straight across in the center, but each end had a taper at a very specific angle. Also, they were worried about helicopter rotor wash. You mount these things on a helicopter, what happens if the wire gets sucked up into the rotor? Well, somebody in the military finally figured out, wait a minute, rotor washes down, not up. Probably not going to have wire sucked up into there, so that problem went away kind of quickly. If we were having problems, 1967, the Army came in and said, okay, this is it, guys. You've had so many problems, we're going to have you fire 50 missiles. You can have 5 failures. You got to have 90% success. First missile we took to Huntsville and fired, failed. Wire broke. Said, uh-oh. They uncrated the second one and fired it. It went stupid and went flying out in the woods somewhere. First 2 shots for failures. Now we only have 3 left. But you know what? We went back and we talked to the manufacturing people. And we said, you've got to get better with this or you're not going to have a job. Not another single missile failed. Every one we took down worked. So in 1968 we started full-scale production. Here's the missiles. This is a very basic tow. This is what it started with. You can see it's a 3.5 feet long, 6-inch diameter, 2.3 mile range. Now remember that 2.3 miles is how long that wire had to spool out. Okay. 2 motors in the missile. You see here the exhaust. This was a flight motor, but there was a launch motor in the back that only worked for a couple milliseconds. And that was to get the missile out of the tube and then let the launch motor kick in. Fielded by the U.S. Army, successfully used in combat, the initial one could penetrate up to 17 inches of Soviet armor. We started the ITO in 1982, weighed a little bit more, but by this time we could penetrate 15 inches of Soviet armor. Then we had TOW 2, you see the probes out on the nose, those are to punch a little hole in the armor and then let the warhead go on in and explode. Improved guidance, but now that probe allowed us to penetrate 35 inches of Soviet armor. And we kept going. Soviets came up with reactive armor. Anybody know what reactive armor is? It's got a couple of sandwiches of armor with explosive in between. The idea is the missile hits that armor will explode and destroy the missile before it can penetrate the armor. So we had to come up with something that would counter that. So that was TOW 2. And finally, where's the weakest point on the tank or an armor? Up on top. That's right. So we came up with TOW B, 2B, top-down attack. 50 pounds, 2 warheads in it. So when it went over the target, it would explode and one of the warheads ought to get it. That's what they look like. That's the stuff inside. I won't dwell on that because we're running along here. Here's a picture of a guy firing it. You see the killer egg. Here's Doc Smith's helicopter. The killer egg flying a tow. Here you see what looks like exhaust coming out. That's not. That's a wire unspooling from the missile. So, what happened after the Magic 50? It eventually became the most successful wire-guided anti-armor missile ever built. Used in all the conflicts since Vietnam. Tripod, multiple vehicles that can be fired off of. In 2004, over 620,000 have been produced, used by more than 50 companies, and they're still being produced today in Tucson by Raytheon. That's what it looks like when it goes over the target. You see the double warhead going off? So that was one of the top-down tows. I wouldn't want to be in that tank.
Take your hearing protector off.
Probably so. That brings us to Maverick. Replacement for the bullpup and for the walleye. Designed for the U.S. Air Force in the beginning. They are used by all of our military. Wide range of tactical targets. It had a use by all three of our services here. And eventually produces as shows here in 10 different variants. Here's some of the aircraft flying them. Off the AV-8B Harrier, the A-10 Thunderbolt II, the F-4 Phantom, and the F-16 Viper. So competition began in 1965 to come up with a fire and forget missile. They didn't want a missile that had to keep the airplane on target steering it. Okay? They wanted something that he could drop and turn and get away, and the missile would know where to keep going to. So, Rockwell and Hughes, a fierce fight between these two companies to get this contract. But Heck had experience with walleye. We actually built the electro-optical system for the walleye missile. Now walleye was not rocket propelled. It was a drop. It was a gravity sort of weapon. We were awarded the contract in 69, 71. We got a contract for $69.9 million. Doesn't sound like a whole lot of money today, but that was in 1971 dollars. And we started delivering in 72. It was a big missile. It was a heavy missile, 462 pounds, and the range was just a little more than 17 miles. Interesting, the TV guide, which was the first one we produced, was linked to a TV in the pilot's cockpit. And the pilot could see exactly what the missile was looking at, and he could slave that missile to go wherever he wanted it to go. The 65B, we began in 1975. We added optical zooming so that it could see further out than just the 17 miles. Didn't increase the range at all, but the pilot could see further. And hazy conditions began delivery in the 70s, ended deliveries in 1978. 65C was started by Rockwell. That was because the U.S. Marines wanted to have their version of the Maverick. It was to be laser guided, so the Marine on the ground could laser designate the target and the missile would find it and go towards it. Canceled before production began. We explain why in a minute. Later met by the Hughes produced 65E. Then came the D, began in 1977. You can see the improvements made to it. This was an IR missile, so it could be a heat seeker. Doubled the practical firing distance because the heat signature would show up better. 485 pounds. Got a little bit heavier for the Marines, but that's, they said, because they were bigger and stronger than the Air Force guys, the Navy guys. 1983, delivered to the USAF. Then came the E model. This was a cancellation of the C. Went to the U.S. Marine Corps, laser designated, increased to 300 pounds, got bigger, operational by 85, and equipped the FA-18 and the AV-8s. Then the F and the G, designed specifically for the Navy. The G model had a heavier penetrator warhead. Test completed in 88. Deliveries began shortly after that. Then we came with an H, and then a J, and the K. So they kept getting bigger and better. It became finally the most widely produced precision-guided missile in the Western world. Over 70,000 of them have been built, and they're still building today. 30 countries, more than 25 aircraft, used in every conflict by the U.S. since Vietnam. Success rate of more than 90% hits. Still being produced by Raytheon. And here is one about to wipe out a tank. Okay? So what's the old saying? Bend over and kiss yourself goodbye. These guys are about dead. Roland, one of the most exasperating programs we ever had. An all-weather short-range defense system. Did you ever hear that one, Bill? Okay. Supposed to replace Chaparral. Army picked it in 1975. Hughes was to build it on license from Euro Missile. That's a combination of a French-German consortium that are going together in Europe to build this missile. Hughes was the prime. Boeing was the secondary to build the tracked vehicle. But we had to use the European fire control system. Procurement was a political decision. So many foreign countries were buying missiles from Hughes and from the U.S. that they were starting to complain that we never bought anything from them. So we needed that short-range missile, so it was determined that that's what we would buy. Picture one going out. These are called sabots. They take up the space in the launcher where the missile does not want to fill up the entire part of the tube, so these sabots surround the missile. Not very big. Hey, but I threw a curve at you here. You notice I put all of it in metric. I'll tell you why in a moment. Production. Supposed to equip 4 battalions and 1,000 missiles. Never got there. The missiles were delivered in sealed tubes. 10 total missiles per unit, 2 on the rails, 4 in each of 2 magazines. Here you can see the 2 on the rails. The magazines were here. The missile would fire. This launcher would kick off that tube, then go down and pick up another one and come right back up into firing position in a matter of seconds. Here you see the search and the track radars. Search up here, track down here. Documentation nightmare. We could not Americanize this missile. MBB insisted that no changes be made without their approval, and they would not approve Americanizing the missile. They were afraid we would take it away from them, I guess. First angle projection on the drawings. Anybody familiar with first and third angle projections? American drawings are made with third angle. Okay, quite simply, if you're looking here, you want to look in here, you kind of flip that out and look. First angle is just reversed. When you look at the plan view, the right side is on the left side is on the right, the top is on the bottom, and the bottom is on the top. Okay?
MBB stands for?
Messerschmitt, Blue Cow, Bloom.
I thought it was that. Yeah.
All metric. We were not permitted to change to decimal inch, and that became a nightmare. French and German language. We received the drawings in French and German, and in some cases a single drawing would have both languages on it. Those all had to be translated. So we had a large group that were translating information. We found that there was incomplete or missing data that was on the drawings. So as I said, minimum design changes, language barriers. We would call Europe to ask questions, and we would get some guy who didn't speak English. We think that was probably intentional, but nevertheless, you can't. But gentleman in the back nodding his head. You've worked with the French? Yeah. Okay. Okay. Not suited for high-rate production. Why? Because they built the missile in mom-and-pop shops all over Germany and France. Each little garage had somebody working in it, and Bill might make the circuit board for the seeker head, and somebody else might make the circuit board for the guidance section. And so they were all little mom-and-pop shops. I said, beat the shape, follow the fit, and paint to match. Some of the drawings actually had words to that effect on there because these parts would come in from different areas and they were just working through their little sketch drawings and they were not all that accurate, so you had to beat them to shape. In a couple of drawings, it actually had a phrase to accomplish this effort, whatever it might be on the drawing, see Otto in the shop. Because Otto had done this for 20 years and he knew how to do it. So you had to go see Otto. Can you imagine trying to do that over here? Circuit board layouts. They were not laid out for auto insert. Hughes by this time had auto insertion equipment. We could take a circuit board and a whole tape full of components and they chunk, 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 and automatically load components into the circuit board. France and Germany didn't do that. Everything was hand soldered. The leads were all hand bent. They were stuck in their little holes, so there was no standard anywhere. So we could not use auto insert because you try to insert a component and the holes weren't there. So they did allow us to relay out the circuit boards. Vendor issues and training. We put a big warning on the front of the drawing. This is metric. Didn't mean anything to some of our vendors. We get a part that was supposed to be about 1 inch long, 25.4 millimeters. And guess what we got back? We got a part that was 25.4 inches, not millimeters. So everything was coming in 10 times the size that it should be. Had to have metric machine tools. No one ever foresaw that. All the issues were eventually overcome. All it took was money. Another firing. So, it was literally a failure. We finally built 27 launchers and 600 missiles. Never did get the tracked carrier to work. It was always an ex-MIM 115, never was type classified. Less than a decade, retired in 1988, and then all cut up. We're getting near the end here. This is AMRAAM. Where's AMRAAM come from? AMRAAM, Advanced Medium Range Air-to-Air Missile. Air Force was a joint program manager, but this missile was also to be used by the Navy and by the Marine Corps. And the Navy didn't like it. Answers your question, Bill. That one was used in combat, but not very successfully. Okay, here's some shots. Got an F-106 launching one. Here's an F-102. Here's a weapons bay and a 102. This, by the way, is a nuclear Genie missile. It was unguided, but was used, intended to be used on large enemy bomber formations. So let's get a little bit bigger. The Air Force wanted something that would go further, fly higher and faster. So Hughes came up with the AIM-47. This was the first missile I got to work on when I went there. Started development in 1958. We were still working on it in 1966. It was intended for the F-108, the Rapier, which was never built, and also for the YF-12. Anybody know what the YF-12 was? The fighter version of the SR-71. Actually, the predecessor of the SR-71. We built 80 of those missiles before both the aircraft were canceled, along with the program, but we did successfully test it from the YF-12. But remember MacArthur's phrase, "I shall return"? Remember this one because it's going to come back in a minute. There it is underneath a YF-12. You can see it looks like an SR, but it's not. It had a single cockpit, single pilot in it. Thing had 3 weapons bays for the missile, 2 aft, 1 up front, and then the other bay held the fire control system for it. And then we came with the AIM-26, a nuclear-armed weapon. Only nuclear-guided missile ever produced for the Air Force. F-102s carried it, quarter-ton low-yield warhead. The idea was fire the missile into the middle of a bomber formation, have it explode and take out all the bombers with one nuclear blast. Never had to use that, thank heavens. So, it was eventually canceled out. Decided it wasn't good to be firing nuclear weapons all over the place. But we also built one that was a conventional warhead. You see it was a pretty good sized missile, 7 feet, 203 pounds, 6 miles, quarter-ton nuclear warhead. And there's a picture of it. Which brings us to Phoenix. How many of you heard of the Phoenix missile for the U.S. Navy? Yeah, a couple of you. Okay. It was a resurrection of the AIM-47. This was where the AIM-47 returned. Hence, Phoenix, it rose from the ashes. Began in the mid-1960s for the F-111B. Anybody remember the F-111B? It was the Navy aircraft we used on carriers. One of McNamara's follies. They wanted to have an F-111 that would work for the Air Force and for the Navy. Found out they couldn't do that. The F-111B got too big and heavy for an aircraft carrier. So they canceled the F-111B. And now we had a superb missile system with no home. So what happened? January, they awarded a contract to Grumman for the F-14 Tomcat. The F-14 Tomcat remains today the only aircraft in the U.S. inventory that was ever designed and built to carry a specific missile system, and that was the Phoenix. Only operational long-range air-to-air missile. There's a shot coming off of a VF-1 Wolfpack. This was our engineering group in 1969 down at Hughes. You see, maybe you can see that's a YAIM, that's a prototype, and that was the first Phoenix actually built from stem to stern in Tucson. And at that time, this was the entire engineering organization for that. This later became several thousand engineers, but this was the beginning. You can see all the men have their white shirts, their ties, and their pocket protectors. That was a requirement, had to have a pocket protector. You see the ladies, younger ones, with a beehive hairdo, okay? And way back here is some young kid that happened to get on that thing, and that was me, 27 years old at the time. So how big was it? Big. You can see the dimensions there. It was big, and it was heavy. And when the government bought it by the pound, it was very expensive. The initial missiles, when we were building them, ran about $3 million each for the test missiles. Interesting flight profile. It would be launched. It would climb up to somewhere between 80 and 100,000 feet. It would look down for its targets. The fire control system itself, out of the F-14, would give the missile a mid-course correction, so it would get headed to where it was supposed to be, and then it would dive on its target using kinetic energy. That's what it looked like. You see we still have coolant connectors. Okay. Simultaneously track and engage multiple targets. Okay, how many could it track? Up to 24 at one time. One F-14 using the fire control system could track 24 separate targets. It could launch up to 6 Phoenix missiles, each targeted to one of those targets. And interestingly enough, while the missiles were en route, the fire control system would continue to interrogate all of those targets. And if one of those targets became a greater threat than the one of the missiles was slaved to, they could change it. They could tell this missile, don't go get that one, you go get this one. And the missile could do that in mid-course. The fire control system itself was nothing small, 1,300 pounds, 28 cubic feet, all sitting in the nose of an F-14. But it not only controlled Phoenix, it had to control the other weapons for the F-14 as well. So it did the AIM-7, that's a Sparrow, the AIM-9 Sidewinder, and the AIM-54. I just threw this in there. I love the look on that cat. That tells you the confidence F-14 pilots had in their airplane and their missile. Interestingly enough, originally tested on an A3D Skywarrior, old Navy airplane, and my daughter happens to work at the Pacific Aviation Museum in Pearl Harbor, Honolulu, and I was over to visit her in November, and walking through their back hangar, and I saw this A3D, except it had Raytheon painted on it, not Hughes. I checked the tail number, and when I came back, I found out that's where this airplane wound up. It's over in Pearl Harbor. So, a very critical test. Remember, this missile and fire control system was supposed to go after multiple aircraft. So, in 1973, there was a test to see if it could actually accomplish what it was supposed to do. The F-14 was over the Pacific Range at a little less than Mach 1. It was at 24,000 feet. There were 6 targets out in front. The F-14 fired 6 missiles over a 38-second period at separate targets. The drones were at different speeds, and they were actually at altitudes from 500 feet up to 80,000 feet. So this fire control system was looking at that whole range of targets and guiding the missiles. We got 4 direct hits. We knocked the drones out of the air. We had 1 that was lethal. It passed close enough that it was scored as a hit. And then they said we have 1 miss. Hughes complained about that. They went back and looked later and found there was a drone augmentation failure. These drones have a black box in them that makes them look bigger on radar, makes them look like a full-size airplane, and the black box wasn't working on that. So Hughes got credit for a hit with that. So we were 6 for 6. Deliveries to the fleet in '74. How many did a F-14 carry? It could carry up to 6, but they seldom did that because of the weight on the airplane. If the F-14 took off from a carrier with 6 missiles aboard, it had to dump several of them if it was coming back to the carrier because it would be too heavy to land on the carrier. Or a couple Sparrows, a couple AIM-9s, and 2 Phoenix, or a combination of AIM-7s, AIM-9s. Here's a load of 6 on the F-14. And this is where they carried them under the pylon. Iran. At one time we were great buddies with Iran, you know. And Iran came to the U.S. and said, we like that F-14 and those Phoenix missiles. We want to buy some. So the U.S. said, certainly, for our good allies in Iran, we'll be happy to do that. So they sold 70 F-14s and 600 AIM-54s to Iran. Grumman and Hughes, Grumman being the F-14 manufacturer and Hughes the Phoenix manufacturer, were to provide all the support and training to the Iranians. But they drove us nuts. They literally drove us nuts. Because when something would break on the aircraft or on the missile, something failed test, our guys wanted to show the Iranians how to fix that. And they said, no, throw it away. It's the will of Allah. You're not going to repair them. Allah would not like that. So that was an issue in trying to save some of our stuff over there. They claimed they had a successful combat record with the Phoenix, 60 to 70 shoot downs, they told us. In our own use, the Phoenix was never used. But with Iran, they claimed 60 to 70 shoot downs. The Iranian Revolution. We lost the F-14s. You remember when the Shah of Iran abdicated and the Ayatollah went in, we lost all those F-14s and AIM-54A models. We learned that within a week, the missiles at least were up in Russia being reverse engineered so they could figure out how to defeat them. So Hughes went into an extensive redesign effort to come up with the 54C and C+. So we stopped production of the A models. We had built 2,566 of them. And we went to C and C+. Now, this is where I got the bags under my eyes. We were working 6 days a week. We would work Monday through Friday, 10 hours a day, Saturday, 8 hours a day, and frequently in there Sunday for 8 hours a day to get this thing redesigned to get a new missile out to the fleet that the Russians couldn't defeat. So we made a number of improvements. You can see what they are there. And in December of '81, we delivered the first prototype to the Navy. Early '83, the first production missiles reached the Navy. Now you notice I jumped from A to C. What about the B? It was to be known as a dry missile. The Phoenix missile had hydraulics. We had tubes, hydraulic lines, pumps, all of those things to drive the actuators and the control surfaces. So we wanted to make a dry missile. We started in '72, got rid of the hydraulics, obviously getting all that stuff out of the missile. We could simplify the construction, built 7 B missiles, and after 2 successful test firings, the missile was canceled for being not cost effective. And what the actual problem was, this was coming in at the end of the Vietnam War. And the Navy did not want to go to Congress asking for more money to build a dry Phoenix missile. So I'm not sure why it wasn't cost effective. Certainly it wasn't on our end, it was on the government end. But like the AIM-47, remember, I shall return. I'll show you where this one came back. So the end of the line, you can see how it pretty much phased down. By '93, the Tomcat was getting old, the missile was getting old. Decided to withdraw the Phoenix in FY04, retire the AIM-54 from fleet service, and then retire the F-14s in 2006. It's very interesting, when the F-14s were retired, they went to the A-Mark down in Tucson, the boneyard, and they were all scrapped. None of them were given to museums. Those were the F-14C models, and what the government was very concerned about was that Iran would get a hold of spare parts. So they didn't want spare parts making their way to there. My feeling was, give them all the spare parts they want, let them put their F-14s in the air, and we could use the F-15s and X-16s to use them as targets, but that didn't go very far. Okay, that was Phoenix. This is TOW. Tube-launched, optically tracked, wire-guided missile. Interesting thing, and there you can see the TOW, designed for anti-armor. The Warsaw Pact Soviet armor. If you remember, during the Cold War, we were all concerned about the Russians over in Europe. The Russian military was based primarily on armor, i.e. tanks. So they wanted something to combat the Russian tanks. So we developed this thing as a ground and helicopter launch for the U.S. Army and for the U.S. Marine Corps. It replaced the old bazooka. You all remember the bazooka? And the 106 millimeter recoilless rifle. Started in the early 1960s, and as I was explaining to the gentleman here a while ago, one of the initial issues was wire snarls and breakages. The wire was 2 thousandths in diameter. It was a copper-metal alloy combination, and there were 2 spools of wire in each missile. Only 2 thousandths of an inch. It was tensile strength such that you could not pull it and break it. But you put a little kink in it and pull it, it broke just like that. How many of you ever gone fishing with an old bait casting reel? Remember the bait casting reels? And what happened if you didn't cast it at the right speed? It all wound up and became a snarl. That was an issue with the wire on the TOW. And it was a wire bobbin winding problem. What we finally figured out is the wire bobbin had to be tapered at each end. The wire bobbin was about that big around, and each bobbin held about 2.5 miles of wire. And that wire off those 2 bobbins had to spool off the Air Force. We were also fighting with Raytheon. They were our primary competitor on this. Return of the AIM-54B. Remember I told you the B missile, dry Phoenix? Well, when the Air Force came along saying we'd like to see a design for an advanced medium range missile, we simply opened the drawer and said, we think we already have it. It's the AIM-54B missile. No hydraulics, no nothing, much smaller. Conceptual 79 rather, Hack and Raytheon selected to continue. Validation phase concluded in '81. Both contractors were to do flight test missiles. full-scale development in 82. Then the Air Force selected Hughes Missile System Group as the full-scale developer. Raytheon was the follower. They filed a suit in court against Hughes and against the Air Force. Said they should have been the leader. They lost. We were to build 94, option for 924 full production. Production approved, low rate initial in 1987. We got 105 rounds, Raytheon got 75 rounds. Guess what? Back to court. They lost again. Okay, to the 1988's began delivery. Tests were by the 33rd Tactical Fighter Wing at Eglin Air Force Base, Florida. I put that in there, nobody really cares, but it was interesting when you go down to Raytheon, or down to Eglin to visit them on the missile. The first thing you saw was a big sign in front of Eglin Air Force Base that said, Eglin Air Force Base, home of the nomads. Stop and think about it. What's a nomad? A nomad's a person with no home. But that's what the sign said. Deliveries in 1991. The Navy was a little bit behind getting the F-18 up to speed. Finally, FY-88 order for 630 missiles, split 55-45 with the biggest share to Hughes. Raytheon didn't go to court that time. I guess they'd already learned they were going to lose that. So continued production approved in 91. Here's an F-15 firing a AMRAAM. So 1991, they achieved operational capability with the F-15. That was followed in 92 by the F-16, followed in 93 by the F-18. So they were all approved to carry the AMRAAM. And the full rate production approved in 1992. 12 feet long, 7 inches in diameter, 21 inches wingspan, about the same size as that dry missile. Interesting on the 120B. The downfall with the 120A is it was not reprogrammable. The problems in the brains of the missile, if you will. You could not reprogram them from the ground. You had to disassemble the missile and change the proms and go ahead and set it up for various targets. As a result of the producibility enhancement, we came up with better stuff here. And we did have the proms finally reprogrammable externally. But I had to bring up the white radome and the software identification fiascos. The Air Force had a brand new program manager on the launcher. He was a lieutenant colonel. He had no wings on his chest, so he was not an aviator at all. But he was a program manager on the launcher. And I was giving a brief, incoming brief to him, and I talked about several things. And he finally says, I want you to do something. And I said, yes, sir. He says, I want you to change the color of the radome. I want it to be gray, like the missile. I said, why? Because an enemy pilot will see that white radome on the missile coming towards him, and he will be able to evade it. And I said, sir, with all due respect, by the time he sees the color of the radome, he's a dead man.
That's right.
I don't care. I want that changed. Well, I don't know how many of you know anything about radomes. They're very carefully engineered, and the composition of a radome is very complex because you have to send radar signals to it, and you have to get them back through it without distortion. So there's a lot of black magic worked into the radomes. We worked for 2 years trying to change the color. This lieutenant colonel said, all you have to do is paint it. Sir, you can't paint a radome and get radar signals through it. So we worked with Dow Corning, who was our producer, for over 2 years. And then this lieutenant colonel moved off. And a new one came in, and I was briefing him, and I said, and then we have the radome color change. He said, why would you want to change the color of the radome? I said, your predecessor asked for it, because he said the enemy pilot could see it coming at him. He said, damn it, by the time the enemy pilot sees it, he's going to be dead. I said, yes, sir, that is correct. You're right. So, we spent a whole lot of money for nothing. And this is some of the waste, fraud, and abuse you hear about by contractors sometimes. Not always our fault. And the software identification, I told you we can now reprogram the software on the missile. So the field service support people for the Air Force came and said, we need some kind of way of identifying what software is in the missile. When we delivered the A missile, there was a color code on it, and they knew what was in there. Came along with this B missile, and I said, well, what would you propose we do? Because you guys can change it. We can deliver it with some software in it, but it won't mean anything. He said, well, we need color bands. We need color bands on them. I said, what's that going to do for you? You can change it. We went into a long exercise to look at different color bands. Finally, another leader came in and said, forget that, that won't work. Thank you, sir. Okay, late 1994, we delivered the tactical missile. There's an F-16 AMRAAM launch. The AIM-120C, we shaved the control surfaces to get it into the F-22 because the weaponry on the F-22 had to be carried in a bay. We're right back to the F-89, the F-102, so they're all in bays. We had to clip the wings, decrease the wingspan, and the Air Force first said, well, all you have to do is cut the tip off the wing. We said, sir, that changes the guidance section, that changes a whole lot of things in the missile. You don't just cut the wing tips off. But it had to be done to get into that airplane. So new control section, aerodynamic changes, range increased to 65 miles, and that was the last of the Hughes-built AMRAAMs. You see the clipped wing, and there is a production wing with the, normally this would have gone on up here and then down here. F-22 firing one, so it worked. There's an FA-18, got 8 of them on there. And the F-35 AMRAAM is, maybe was, the only missile actually cleared to operate off of the F-35 right now. So the 120 summary, 30 plus years, 37 countries, number of aircraft, both ours and others. Only air-to-air guided missile on the F-35, 1.8 million captive carry hours, 2,900 live firings, 17,500 produced. And they have been used in combat, and they have not missed a single enemy aircraft.
Good.
Just real quickly, angle rate bombing set right here we built for the Marines and the Navy. Makes a dumb bomb smart. Literally is a modern day Norden bomb sight. This thing can compute wind speeds, air speeds, aircraft speeds, all of that, and tell the pilot when to drop the bomb. These were lightweight launchers that we built for a period of time. I was lucky enough to be in Huntsville to see the first firing of one of these. This is phenolic. This is like cardboard that's been impregnated. The idea was you could use these things 5 times and then throw them away. On the very first test on this one, we ripple fired it, and on about the 3rd or 4th missile out, it burned through the tube, and they had missiles going everywhere down there. Rockets ready, not a good idea.
It's called exciting.
It's called exciting. Yeah, it's called go change your shorts when you're done. We also worked on the Raytheon Hawk missile on what was a highly classified project. Not even Raytheon knew we were doing this one. And primarily it was new electronics to potentially intercept ballistic missiles. SDI, Star Wars. Hughes was deeply involved in Star Wars. I worked on that for a very short period of time, but you all know what Star Wars was supposed to do, and it is a workable program, regardless of what you might hear. Products acquired from General Dynamics. We bought General Dynamics later on and picked up 4 missiles from them. So what happened to Hughes Aircraft Company? 1985, the Howard Hughes Medical Institute decided to get out of the business, sold Hughes Aircraft to General Motors for $5.2 billion. Now that was 1985, so it was a lot of money. But remember that $5.2 billion, because I'm coming back to that in just a second. What did that mean? Hughes is no longer privately owned. We had to satisfy stockholders. Made a big change in the way the company was operating. GM, if you remember, the mid-1980s was having a lot of problems. They were profit-driven to satisfy the shareholders. First thing they did was merge Hack with Delco Electronics, who was about to go bankrupt. Research and development money disappeared. General Motors took that money off and used it for something else. Hughes always prided themselves on having R&D money in the coffers, and we spent it. We tried to stay ahead of what we thought the military was going to ask for. It disappeared with General Motors. Investment funding new products, GM said, no, not going to do that. And then perhaps the worst of all was what they called right sizing. Prior to that, it was downsizing. Prior to that, it was layoffs. Okay? Hughes would always keep an engineering team intact, even if we didn't have a contract in the immediate future. We knew contracts were coming. If we did not have work for an engineering team, Hughes would pay for those people to stay on board until we did get the contract. First thing General Motors said was, if you don't have work for those people for the next 3 weeks, lay them off. Get rid of them. Because they'll come back. Where else can they go to build missiles? They'll come back. Guess what? We laid them off, and they didn't come back. So that hurt us. 1992 to 2003. 92, Hughes, as I mentioned, purchased General Dynamics Missile Systems. By 95, Space and Com, the builder of the satellites, was the largest supplier in the free world. However, with declining defense budgets, 1997, the aerospace and defense ops was sold by General Motors to Raytheon, our prime competitor, for $9.5 billion. Remember, they bought it for $5.2 billion. Now they ran it into the ground and ruined the company and sold it for $9.5 billion. Not a bad profit return. If I sound a little bitter, I am, because they ruined the company. Space and Comms was then sold by GM to Boeing. Hughes Electronics was the last vestige of the Hughes Aircraft Company. It was sold to News Corp and is now DirecTV. The little antennas you have through DirecTV were designed initially and built by Hughes. So after 75 years, 28 to 2003, Hughes Aircraft was gone. Okay. And that's it. With Hughes Aircraft being gone, I'm gone. Unless you have some questions, I'd be glad to ask.
Well, thank you so much. Do you have any questions? There's a lot of material that was covered there. We have a little something here for you.
So once it's well, I'm not supposed to let someone
No. We're good there. Although I do have heavier things in there. This is a little plaque, an appreciation for your presentation. It says Larry A. Eternal, April 21st, 2016, Desert Warriors and Museum. And thank you so much for your time.
Thank you, sir.
Appreciate it.
That wasn't made by the used company.
No.